Hello and welcome everyone. Thank you for joining us today for this webinar. So I would like to introduce you with our Geo AI platform, AeroMegh Intelligence. Give me a moment, I'll just share my screen. Okay, so today I am going to take you through an exciting transformation that's happening in power infrastructure monitoring. So we'll explore like how drones, thermal imaging, and the artificial intelligence are coming together through our AeroMegh Intelligence platform. Uh, we would like to make this power line inspection faster, safer, and smarter. Let's take a moment to understand like how critical this power infrastructure really is. So electricity, this powers almost every aspect of our daily life. Whether it's lighting our homes, running hospitals, keeping factories alive, running, or enabling the digital communication. So we can say that these power lines are silent highways that carry this electricity from generation plants to cities, towns, and even the most remote villages. They stretch across diverse terrains like mountains, forests, rivers, and even the urban landscapes. Now that's thousands, sometimes even millions of kilometers of wire, poles, and the equipments exposed to different types of weather, wear and tear, and unexpected challenges like storms or the wildlife. Now imagine the responsibility of keeping all of that running 24/7. And even a small defect that left unchecked can cause a major power outages or even spark fires. So that's why inspecting and maintaining power lines is not just important, it's essential to ensure a safe, reliable, and uninterrupted flow of electricity. Now just look at India. We have one of the largest power networks in the world. And these power lines carry electricity across cities, towns, and villages, even through the forests and deserts. Now, as the demand for electricity keeps growing, we need to ensure these lines remain safe and functional. So let's understand like how big this opportunity is, not just in India but globally. India has one of the world's largest and fastest growing power grids, with over 12 millions of circuit kilometers of transmission and distribution lines. And that's a massive network spanning cities, towns, forests, hills, and deserts. And it's only growing. So, this definitely makes India a huge opportunity for AI driven automation in the power infrastructure inspection. So whether it's remote rural lines in India, any utility corridors in the Middle East, or the aging infrastructure in Europe, the use case is the same: faster, safer, smarter inspections powered by AI and drones. Now the challenge is that these lines stretch for millions of kilometers, and inspecting them manually is extremely and a time-consuming task. And that's here how AI plays an important role in inspecting these power infrastructures. So basically, traditionally inspections were carried out by people on foot, even sometimes with the help of helicopters. So while these methods worked in the past, they are no longer practical. And first, they are very slow, and it can take days to inspect a single stretch of line. Second, they are risky, especially when working at height or even near the live wires. And finally, they often miss subtle faults like internal overheating or any timing crack or even any missing component that are not visible to the naked eye. On the top of that, these methods don't give us any consistent or measurable data for the planning. Now let's take a moment to some common defects in the power lines. So these defects are just the sample ones, and these are very can be sometimes very critical. For example, if there is any plate rusting or any ground vegetation, if there's excessive vegetation that can cause fire around the transmission towers, if there's any vibration damper damage or any missing bolts, so any kind of missing component can be a critical defect that needs to be identified before time. And here are some common components that can be identified through our platform. Like we can identify whether they are present or not, whether they are rusting or not. So any type of default or any type of fault in these components can be identified through AeroMegh platform. Now our objective is very clear, to automate the detection of these invisible threats using drone technology and artificial intelligence. Question is why? Because manual methods are not scalable, and in today's world we need inspections that are not just fast but also reliable and consistent. And AI helps us shift from this reactive maintenance to the predictive maintenance, where we can identify the issues before they become serious. And this will definitely can help the power companies save time, money, and avoid the blackouts. And this is where AeroMegh Intelligence comes in. So our Geo AI cloud-based platform built by PDRL uses artificial intelligence to process images captured by the drones, whether the thermal images or the RGB ones. So AI analyzes these images, detects any kind of faults, any kind of component, and classify their type, plus classify their severity level, and then generates a standardized inspection reports. What's great is that these reports are visual, like as I showed you earlier. You can get the visual annotation of the defects and the components in the report. These reports are very detailed, and you will get the lateral of that particular defect in the report as well, with their severity level markings, and they are ready to use for the ground teams. This platform also marks the GPS coordinates of every detected fault. So the requirement is that you need to upload your geotagged images on the platform, and the GPS coordinates of each and every fault detected will be reflected in the report. Now, just before going to the live demonstration, I'll just give you a overview of the workflow, like how AeroMegh works. So the workflow goes like, first the high resolution RGB and the thermal drone captured images needs to be uploaded to our secure AeroMegh cloud platform. Once these images are uploaded, we need to train our detectors for the faults or any kind of components that we need to identify. So our platform is giving you the feasibility to train your own detectors, your own ML models. Once the detector is ready, the AI will get to work. It will analyze the images, detect the faults or any kind of missing component, identifies what they are on their type and their classes. We can also mark how severe these defects are, and we can get the exact location of that fault. And from there, it will generate a report that can be directly shared with the maintenance team. The best part is that once your detector is trained, we can use the same detector to as many images to detect for that particular defect or component. So we can say that everything is streamlined. So once you have trained your detector on one image set, you can use the same detector to many other image sets for your use case. Now let me give you a brief demo on the platform. One second, I'm just switching my screen. visible? So, AeroMegh Intelligence is the advanced Geo AI powered software designed to transform this drone capture data into the actionable insights. Now, our platform provides you with an end-to-end solution for the geospatial data. It will help the industries to optimize their operations and make the data-driven decisions. So, our platform offers a powerful AI-driven analytics, including object detection, anomaly detection, change monitoring, and predictive analysis. And it will making it highly valuable for the applications in agricultural, infrastructure, urban planning, transmission, solar, and asset management. So, AeroMegh Intelligence works on the application where you need to upload your GIS or GeoTIFF images. The orthomosaic needs to be uploaded on this platform. On the same, you can train your detectors and use the detectors for further images as well. Now, there are some use cases like power transmission and wind mile use cases in which there's not feasible to generate the orthomosaic images, and you need to analyze the defects or faults on the raw drone imageries only. So for that, we have our extension, that is Pickstock. This is the platform and this is the dashboard of Pickstock, where you can do the same work but on the raw images. So application is totally same. As you can see, this is the dashboard for Pickstock. You can see this is the images, like how many images has been uploaded on this account. So you just need to sign up on our account on Pickstock or aeromegh.com, and you will be diverted to this dashboard. Then this tab will show the number of objects that been detected on this account, and the task has been created. And these are the detectors tab, where you can see the number of detectors you can create on your own data set actually. So it is very seamless integration or a seamless dashboard. To start with, you need to click on this start button. Now here are three types of tasks available: the training, annotation report, and the detection. As I mentioned, like AeroMegh is giving you the feasibility where you can train your own detector. And for that, you need to create this training task. In this task, you need to upload your images, the raw images in the JPEG or the PNG format. Once your images has been uploaded, you need to, with the minimum annotations, because you need to do the annotation on some of the objects to train your ML model, and you can start the task. Once your detector is trained, you can use the same detector in this detection task. So if you are selecting the detection task, you just need to upload your images on which you want to identify the faults or components. So once your images are uploaded, you just need to assign the detector, and rest AI will take care. It will analyze all your images. It will list out all the faults from your image set, and will give you the consolidated report for that. And you can download your report in the PDF format. Now, this is an annotation task where you can do the manual annotation. Let's say if you do not want to train your own detector and do not, go in the whole process of training and detection tasks, so you can simply upload your images, annotate your objects, like just a bounding box with the, or digitize your annotations or your faults which you need to identify, and you can simply just download the reports. So there's no need to train or a detector or do the annotations. Now to start with, I'll show you how to train a detector. We'll click on this training task. Firstly, you need to create a project. Let's say transmission zone 2. Now my project has been created, and Now I need to give the task a name. Please note that in the training task, whatever with which detector name you want to train your detector, you should give the detection task name that only. Like, so I'm just training the detector with the name transmission faults, and just need to click on this create task. Now your task has been created for the training. Then you can create your image set. Once the image set is created, you need to upload the images from this tab. So there are several options from where you can upload your images. Uh, Let me show you the uploaded images. So this is, I already have uploaded some images just to save time. So I have created the task with the name transmission detector training, and in this tab I already have uploaded the image set. So once the images are uploaded, this is how it will look like, and you just need to click on this annotate button. It will take a few seconds for the resizing of the images. So the process is very simple with a minimum annotations of each class that you need to identify, and you can annotate your image set. Now images have been uploaded and we can select on an image. Now you need to give the class name. What is class is basically the object that we need to identify or any kind of fault. For example, I'm adding a few classes: insulator, damper, arcing horns. So I'm adding these four classes that we can mark or annotate on our image. Now, to annotate, I need to click on this class which I am annotating on my image. Then we have this toolbox where we can have features like rectangle, polygon, and circle, with the help of which we can annotate our objects. So I'll choose this rectangle. And the annotation process is very easy. I add one more class. And this is how you need to annotate your images. I'll just quickly, just to show you, I'll quickly mark, because the requirement is that you need to annotate at least 20 images in order to start training of your detector. We can also copy paste the annotations and paste on the required component. So if there's any missing component, that can be a critical thing that needs to be identified before, that can definitely leads to a major issue later on. So this can be detected from this. like this we can mark any kind of object or any kind of faults. Right now I'm just giving for the example. We need to annotate at least 20 images. So as you can see, this annotate button is not been highlighted. Now it is highlighted as setup button. So because all the 20 images has been annotated. So this is a minimum actually. You can annotate as many images as you want to increase the accuracy of your model. Once your images has been annotated, you just need to click on the setup button and it will be starting. The process will be start. So here you can see the classes which we have identified or added in our detector, and against which how many numbers of annotations we have created. So to start, we just need to click on this start button and training task will be started. Let me show you how it will look once your training will be completed. So once your training will be completed, it will show you as completed from as you can see here, and all your classes will be displayed what we already have annotated. Now our detector has been trained with the name of the task which we have created in the training task. Now we can use this detector for the detection directly from here as well by clicking on this detection task. And just need to click on this create task. And again, if you have some other image set that on which you want to assign your detector, you can again create your image set, then upload your images. And if you already have uploaded one, so you can simply click on the image set and click on this setup button. You can select the processing parameters, like if what is your objective for this detection, like whether you want to just count the objects or you want to identify the faults, and in which shape you want your output as, like in the polygon or the bounding box. And from here you can select your transmission tower or any kind of detector that you want to assign. So because from the training task directly I have assigned or created this detection task, so this detector is already available in my selection. But if you want to add more detectors, so the feasibility is also for, like, you can add multiple detectors on your same image set. So whether, for example, if you have a different detector for the components and a different detector for the faults, so you want to identify both in your image set, so you can simply just add multiple detectors on the same image set. For example, I'll just add these two and the number of classes, like in this transmission tower detector I have these number of classes available that I can identify. But in case amongst these I do not want to add any kind of class, or I do not want to include these in my detection task, so I can simply just remove them. And for the rest of the classes, this detection task will run. We can simply just click on the start button and it will be started. Let me show you the detection task. Now once your detection will be completed, this is how it will appear. Your number of detections will be seen here. And to see the report, you can click on this detailed report. So this is a detection task. For this we have trained our detector and assigned that detector on my image set, and you can see with minimum of annotations we get the maximum of result. Like on all the images I got 136 insulators identified, 80 dampers identified, and rest like this. So to check the annotations, we can click on any particular image and we can see the results like this. So we plus we have a feasibility where we can modify our detections as well. So we can simply click on this edit button, select any of our annotation. If you want to edit it or copy paste it or delete it, so we can do that. So it will increase the accuracy, plus it will also reflect in our report. So these are the detection reports. So you can see in this single image, this much of components and faults has been identified. Now to see the report, we just need to click on this view report button, and this is how the report will look like. Right now there is a option where you can see the lat long and altitude. In my image set this information was not available, so it's not visible in the report. But if you have the geotagged images, then you will get the lat long of that particular fault also in this report, and you can download your report in the PDF format. So in the report you will get the class name, like the type of object that's identified, and if you want to add a remark or the severity. Now let me show you how you can mark the severity. So once your detection task is completed, you can simply mark the severity. It depends, like for example, if there's any missing component, so it can be a critical thing to be to be left over. So we can simply mark this component or this fault as the severe one. So we need to click on this to edit, and we can mark the severity. It depends on the criteria that as per your use case, like it can be a higher severity, and plus we can mention the people that we need immediate action for this component to be replaced. So we can mark them. Like if I mark for this, we need to add the team with team functionalities there, where we can add the team members, and with them we can share our project. I'll show you the team functionality later on. Right now we can simply mark that person, and the person will get the notification or the email for the immediate action. And this is how the report will look like. And there's a summary report as well, where we can see the the all the classes that are identified with their respective number of annotations in the whole image set. So this is how training and detection tasks works. Like firstly, you need to train your detector with a minimum of annotations, and then the same detector can be used in the detection task, where you just need to upload your imagery and assign the detector, and rest AI will do the work. One more task is there, like the annotation task. For that, you can simply click on this annotation report. In this task, you don't need to train any kind of detector. You simply just create a project, give the task name, um, and upload your image set. Again, I'll add this image set and click on this setup. You need to add the class that we need to identify, like isolator or hotspots. then just click on start, and within some seconds it will be completed. Once the status is completed, we can start annotating. Like this completed now, and we can click on this detailed report and we can start annotating. So for this, we don't need to train any kind of detector. We can simply start with the annotation process. Because it's a thermal data, so it will calculate the temperature also for this particular component or particular uh, object that we are identifying or the annotating. So this is how the manual annotation works. Like in this, you don't need to train any kind of detector, and with the temperature tab, you will get the temperature of these annotations. To see the report, we can click on this, then view report, and all the information will be reflected in the report. Now you can see, because this data set is geotagged, so we'll get the lat long plus altitude of this image. Again, with this task also, if you want to mark any remark or tag any person for that particular defect, that can be done. And if you mark any severity, so your report will be can be classified on the basis of the severity level, and that can be reflected. So this is the training, testing, and the annotation report. Now detection task has been created, and I showed you. There is a team functionality also. Like if we click on this teams, we can invite any our team member. Like they need to sign up on AeroMegh first, and then they can simply just we can share our projects with them, and they'll get the invite, and then they can use the same project to work on. For example, I already and once they accept the invite, they'll show as the active member on your account. And now, how basically you can share your projects are. For example, if I want to share my project, I need to click on this manage, and I can these are my active team members already. So I can give the limited access to the particular member for any kind of project, like operator, guest, manager, and viewer. So what this limited access basically works as, like manager get the full access of this project. Like they can manage your projects, they can assign the detectors, they can run the detections and view the results. The operator can only annotate and run the detectors, and they can view the results, but they are not able to manage any team access. Plus, viewer will get only the read only access, so they can view your project, but they cannot download the reports. And guest will get the limited visibility, like they will get the access to only specific components on the platform. So to give the access, I can give the operator access or any kind of access that we want to give to that particular team member. So just need to deselect the role and to click on this plus button, and they will get the notification on their account that someone has shared the project with you. Then there's a planner feature on AeroMegh where we can plan our task, like we can assign a task, and this feature will be helpful for the enterprise level companies. Like they can manage their projects, they can assign the projects to their team members. For example, like zone 1 task. Now you can set the priority, like is it low, medium or high priority of that particular project. Then we can assign that team member on to which we need to assign the task. Now on which what type of task is this? For example, I am on the images. On pick stock we need to assign the task, so we can select the pick stock images. And then what is the project to work on, so I'll click on this zone 1. That project we need to assign to the team member, that needs to be selected here. Then on which image set we want they should work on, so we can select that image set and click on this assign task, and they will get this notification on their email. And you will also get this in your calendar or planner. Then we have assigned this task to that team member, and if you want to modify it, so we can update that as well. uh, Plus if what they will do, they can also update that, and we'll get the notification, or we'll get this in the by clicking on here, like if this task has been completed or not. So this is how we can manage our task, and the process is very seamless. So this is how AeroMegh works. Now let me show you. One second. So it was the workflow. So I already have showed you like what are the severity classification and how it will be appear in the output. So once the faults are detected, we can classify them into the 3 levels, like low, medium or high severity. Like any minor heating or early vegetation growth, that can be marked as low because they are not very much critical and not harming and not need any immediate action. But a faulty insulator or any component missing, that need an urgent attention, so that can be marked as on the high severity. So these severities levels are reflected in the report as well, which making it easy for the decision making. And the final output includes the annotated images, GPS data, and complete fault details along with the severity markings. And as I showed you the thermal data, so in case of thermal data, when you click on the hotspot, it gives you the details like the defect type, the temperature reading, and the location coordinates. So it definitely makes it easy for the field teams to plan any repairs or any kind of action that needs to be taken. Now let's talk about some benefits of AeroMegh. First, it's fast, and our solution are can inspect the several kilometers of lines of data in a single task. Uh, as I showed you, it was very easy with the minimum of annotations. You can train your detector, plus you can assign the that detector on the other images as well. So basically it's accurate, and the AI has this high detection rate, so it definitely can improve over time. Plus it's also safe because there's no need to send humans to close to those live wires. Plus it reduces the cost by avoiding any emergency repairs and reactive site visits. And the best part is that it brings consistency, so you will get a standardized repeatable way to inspect and monitor asset over time. Plus we have this seamless integration, enterprise integration feasibility, like our platform is built on is built with the APIs. So to integrate directly to your enterprise or your enterprise asset management system, we can simply provide these API to your system, so you can access the data and download the reports on your own. These are some key benefits for the utilities. Like, why does this actually matter to the power companies? First, they can prevent the outages before they happen. Then, of course, inspections are safer and don't need any physical access with the AI. Plus, it cuts down the emergency repair cost. So if you will get the report before ahead, the fault is actually happened. So you will definitely, cuts down that emergency repair cost. Plus, this system runs more reliably and it's scalable. Like, it works for these small towns or even large cities. Plus, it gives a clear objective data for planning. Now, the platform automatically generates this clear detailed reports once the detection is complete, and these reports aren't just a list of components. Actually, they actually include the visuals of the annotated detector or annotated object or fault with the GPS coordinates. We can get the fault categories plus their severity levels, so teams on the ground don't have to interpret the raw data. They actually get the actionable insights. And to summarize, this power line infrastructure is too important to left to slow or inconsistent inspections. So AeroMegh actually offers a smarter way where we have combined the speed and safety of drones with the intelligence of AI to deliver a complete solution. So whether it's a major utility or a regional operator, AeroMegh can scale to fit your needs and help you make informed and predictive maintenance decisions. Thank you all for staying with me through this session. I hope it gave you a good understanding of how drone and AI automation are transforming this power line inspection. Now, if you have any questions, so please feel free to ask. Garima, over to you. Thank you, everyone.
Thank you, Garima, for an insightful session. So I hope everyone had an quite a learning about how AI is powering power transmission, and we are open to questions and answers. So I would request everyone to drop in a message, or they can also unmute themselves and ask their questions. We are open to that. Anybody, any questions?
गरिमा, मुझे ये चीज करना था, मुझे चेक करना है, मुझे मेंबर्स को कैसे चेक कर सकते हैं जो मेंबर टिल्टिंग होती है?
Member tracing. Okay. Thank you for your question.
Yeah, thank you, sir. So if you have, I already have shown you in the Teams feature. Let me share my screen. So here you can see, like, these are your total members, which we have activated on our account. So for any sign up account, they can, send the invite to their respective team members or any stakeholder with which they want to share their projects. And in under this Teams function or the Teams tab, they can see all the active members with which they want to share their projects.
I hope that answer your questions. Any other question, Mr. Dharma? Okay. Next from Hornbill Technologies, may I invite you to ask your question, please?
Yeah, hi. So it's an interesting session,
Sure.
Garima and
Thank you so
yeah,
much.
team. So one thing, like, do you offer any data collection services or only the processing and report?
We don't offer data services, collection services. We only we are a software company. So we have, if you have a requirement, we can connect you with our partners. So we have collaboration with few of drone service providers over the industry, which help us to capture the data, and we can do end-to-end processing and delivery for you, or we can also provide you a platform where you can take up your data and do annotation and analysis.
Okay. And do you have some pricing or something that is in place for this
Yes,
analysis?
there is. Our pricing is available on the website. So we have three plans: Pro, Business, and Enterprise. So monthly and yearly costings are given on the website itself, stating the storage and processing credits on it. So if you have any special requirements or any special customization, that is also we are open to. So you can always share your details in scope of work in detail over the email, and we can give you a costing as per your use case. I'll drop down my email ID also in the chat so that you can revert to us anytime when you feel like.
Sure. Thank you.
Yes, thank you so much. Anybody else for the questions, please? Okay.
गरिमा, मैंने पूछा था tilted members कैसे चेक कर सकते हैं ट्रांसमिशन लाइन पे?
Sorry.
गर्मी के सीजन में मेंबर्स जो होते हैं ना वो टिल्ट हो जाते हैं, वो कैसे
Okay.
चेक कर सकते हैं और उसकी एक्यूरेसी?
Tilted members. So you want to see you might be having certain examples of the faults you are having, or sample data sets. So if you are seeing that it is a little bit tilted, you can also measure it. So there is a measuring tool also available. Otherwise, what you can do is whatever is your fault, you can make your ML learn or detector learn about it, and you can train your detector that way, and you can detect all those things. So it's an open tool where you can create your own detector as per your use case, as per your understanding of the faults which are available on the grounds. We have only showed you certain examples which we had from our previous data sets which we have gotten from our clients, or which studies which we have done for the clients. But every aspect and every data capturing and every project is different from one and another. So this ML tool is mostly very dynamic in nature, so that you can train your own data sets, create your own AI ML model on the basis of your learnings, and do the detection and analysis that. I hope that answers your question, Mr. Taro. The questions, please feel free to write to us. Otherwise, you can visit our website also. We have materials available on our web platform as well, and we are always open for your questions and queries. And I would like to conclude this today. Thank you so much all for joining in. Thank you, Garima, for your wonderful insights. And I hope this session was completely knowledgeable for everybody, and they might have learned something new or we'll be more than happy for everyone to give their opinions on the webinar coming across, and we'll be happy to welcome all the reviews and your queries to us. Thank you so much all for joining in today, and hope you all have a good day ahead. Thank you so much.